Okay, so today we are going to go over the day one notes for 5.2. 5.2 involves the sum and difference formulas. So I know I am going to be evaluating a lot of trig functions at specific angles. So I drew out my first quadrant just to help myself. And the first thing that I wanted to go over real quick is just to remind you that cosine, sine, and tangent and their reciprocals are not distributive. Okay, so let's think about this. If we have the cosine of pi over 4, okay, I think that you would all agree with me that pi over 4 is equal to pi over 4 plus 0. But I want to show you that the cosine of an angle is not equal to the cosine of the first plus the cosine of the second. Okay, these are not equal. So let's just prove that with numbers, right? We know that the cosine of pi over 4, it's our x coordinate, is pi over 2 over 2. Cosine of pi over 4, again, is square root of 2 over 2. But what is the cosine of 0? The cosine of 0 is 1. Is square root of 2 over 2 equal to the square root of 2 over 2 plus 1? No, that is not true. Okay, and because this is not true, because it's not distributive like this, we do have some formulas that we can use instead. Okay, online you can find some lovely derivations of these formulas. Your textbook has some lovely derivations of these formulas. I'm not going to spend the time going through it, but if you are interested in where these came from, you can most definitely find them. You also will be given these formulas on your next quiz. Okay, so long term, it might be important for some of you, especially those going on to calculus, to memorize these. Short term, it's not something you need to memorize. Okay, the first thing that we're going to do is we're going to review. And we're going to just talk about the base angles that we know exact trig values for using the unit circle. Okay, and so these are our angles in the first quadrant. Okay, we know we have in degrees, we have 30 degrees, 45 degrees, and 60 degrees. And in terms of radians, that's equivalent to pi over 6, pi over 4, and pi over 3. Okay, so the trick here is we're going to use these base angles to write sum and differences of other angles. Okay, and this sort of is one of those things, it's trial and error, and it's also, as you see more of these, you should be able to recognize more. Okay, so let's think of an example. If I have 75 degrees, hopefully you can see pretty quickly that that would be equal to 30 degrees plus 45 degrees. Okay, so we're just rewriting the value as an equivalent sum. Hopefully you can also see we have a few choices for 15 degrees. Okay, we could do 45 degrees minus 30 degrees. That's going to be equal to 15 degrees. Or equivalently, we could do 60 degrees minus 45 degrees. Okay, that's also going to be equal to 15 degrees. Our radian measures always seem to give people a little more problem. Okay, once I see that this is in terms of twelfths, I'm going to rewrite my fractions. I have 2 pi over 12. Okay, that's equivalent in twelfths. I have 3 pi over 12. That's equivalent to pi over 4. And I have 4 pi over 12. That's equivalent to pi over 3. So now, hopefully you can see pretty quickly that this would be 3 pi over 12 plus 4 pi over 12. And just so that it's in terms of my reference angles that I'm used to, I'm going to rewrite this as pi over 4 plus pi over 3. And as always, if you can go right here in your head, you don't have to do this extra step. Okay, but I wanted to show that extra step up here. Okay, and the same with pi over 12. For our difference, we actually have two options. We could do 3 pi over 12 minus 2 pi over 12, which is going to give a, okay, that's going to give us 1 pi over 12 or pi over 12. So I can see that that was my pi over 4 minus pi over 6. Or similarly, we could do 4 pi over 12 minus 3 pi over 12, which is pi over 3 minus pi over 4. Oop. Sorry if that's hard to see that one. Okay, so again, you are just rewriting your fraction in terms of a sum or a difference. Okay, so here are your sum and difference trig formulas. So I'm just going to go through the first one, but these really are plug and chug. If you have the cosine of a sum of an angle, you're going to take the cosine of the first angle, multiply it by the cosine of the second angle, and then you're going to subtract the product of the sine of the first angle times the sine of the second angle. Okay, this is alpha, and I think we've discussed this, but maybe we haven't. This b is beta. Okay, and so again, you will have these formulas on your next quiz. So for our first example, we want to use the sum formulas, which are all of these, the sum and difference formulas, to find an exact value. Okay, we already found this up above. We have that 7 pi over 12 is pi over 4 plus pi over 3. So I'm going to rewrite this as sine of pi over 4 plus pi over 3. And now I'm just going to use my formula. Okay, I am looking at the sine of the sum, so I'm using this formula. So it is the sine of the first, so sine of pi over 4, times the cosine of the second, plus the cosine of the first, times the sine of the second. Okay, I'm just implementing this formula. I always check sine of the first, cosine of the second, cosine of the first, sine of the second. Okay, and pause the video and evaluate these expressions. Okay, so my sine of pi over 4 was square root of 2 over 2. My cosine pi over 3 was 1/2. My cosine of pi over 4 was square root of 2 over 2. My sine of pi over 3 was square root of 3 over 2. Okay, again, if you're not remembering, you're going here. Cosine is our first, sine is our second. And now we're just going to simplify this. This becomes square root of 2 over 4 plus square root of 6 over 4. I am okay with an answer like that. A lot of times on a multiple choice test, you'll see square root of 2 plus square root of 6 over 4. Okay, and so this is your final answer. Okay, so let's move on and let's write our cosine 75 degrees. Okay, I'm going to write that as cosine of 30 degrees plus 45 degrees. Okay, all I did was rewrite my 75 degrees in terms of two angles so that I can use, 75 degrees is not one of my reference angles, one of my special angles. Okay, so I rewrote it in terms of two special angles. So now I'm looking at I need to pick the right formula to use. I'm looking at my cosine of a sum. And so this becomes the cosine of my first angle times the cosine of my second angle minus the sine of my first angle times the sine of my second angle. Okay. Again, I check cosine, cosine. I use the different angles. Minus, sine, sine. I use the different angles. Okay, so pause the video and actually see if you can come up with your final answer. Okay, hopefully you've found the same value as me. Cosine of 30 was square root of 3 over 2. Cosine 45 was square root of 2 over 2. Sine of 30 was 1/2. Sine of 45 degrees was square root of 2 over 2. I simplified and I combined. Okay, like I said, I would accept this as an okay answer. A lot of times you rewrite it one more. Okay, so next we are going to use the difference formulas to find each exact value. So again, we found this above for pi over 12. You can use either one. Okay, I'm going to use our top one, pi over 4 minus pi over 6. So this becomes cosine of pi over 4 minus pi over 6. And again, I'm looking up above at my formula. I want to use my cosine of a difference. Okay, so that shows me that it's the cosine of the first angle times the cosine of the second angle. Notice it's not a negative. Okay, the formula says that for the negative, we use just whatever the angle measure is. Okay, and then this is plus the sine of the first angle times the sine of the second angle. So again, please pause the video and evaluate these and simplify. Okay, so I ended up, after evaluating, with square root of 6 plus square root of 2 all over 4. Okay, if you have any questions about this, pause the video and look through and see where your mistake was. Okay, moving on to tan negative pi over 12. So this time we only have pi over 12, but I can notice that if I switch any of these, right, if I do 2 pi over 12 minus 3 pi over 12, I'm going to get that negative pi over 12. So I am going to rewrite this as the tangent of pi over 6 minus pi over 4. Okay, so now looking at my formulas, I have the tangent of the difference of two angles. Okay, so I'm going to use this bottom formula. So all I'm doing is plugging in. I have tangent of the first angle minus tangent of the second angle. And that's all over 1 plus the tangent of the first angle times the tangent of the second angle. Okay, so I would be looking for this whole expression in the represent portion of your quiz. Okay, rewriting the formula with the correct angle measures put in. Okay, so again, take a second, evaluate all of these values, and pause the video and come back when you've done that. Okay, I would definitely suggest going back to the notes and looking at these. And if you have questions about the arithmetic, because that's really what this is now, since we're dealing with numbers, come for extra help. Okay, I evaluated, I rewrote with a common denominator. I simplified the complex fraction, that was right here. Then I needed to rationalize the denominator, that got me here. And my final answer, once I simplified, was -2 plus the square root of 3. Okay, ugly simplification with radicals, but definitely something you need to be able to do. Please make sure to watch part 2 of the video.